So guys, let's continue with the general engineering block. We're going to talk about computer solving, and yes, we use it a lot in engineering, especially in chemical engineering as well. But let me show you the typical ones. So we're going to be using this type of software. Visual Basic is a little bit for coding and making little programs, macros even. We use Word and PowerPoint, yes, a little bit. But the important one here is Excel, which has plenty of useful, let's say, operations and other applications that we may use in order to get solutions. We also have this beautiful, I think this is SYLLABUS, no, it's MATLAB. So MATLAB is also for design, equations, graphing, and essentially that's what I wanted to show you. Also, we have these, what I call these numerical methods. Our methods use it to solve equations. So maybe you've seen problems or mathematical problems that are pretty easy. Maybe one equation or two equations, two variables, two equations, so you can do it. But let's say you have this data and you have this equation and you want to extrapolate what will be this right here, or you want to find a value by going through here. So we use plenty of numerical methods. We also, let's say, the integral of a function is the, let's say, the addition under the curve. But if we don't have this function, we only have points, well, I know a very good numerical method is to eventually, it's called the Euler's or Euler, whatever you want to call it. In German will be Euler. So you have this and you build little blocks right here and you add up all these right here, and the area is very proximate to the area under the curve, which is, of course, the integral value. So there are plenty of numerical methods that you will see. I'm just showing you what's the meaning of that, and it will help us, especially in software in which we cannot set up equations, but we can actually set up numerical methods. This is useful not only because we want to solve this. Many times it's complex math, many times are simple math, but they consume a lot of time. So if I tell you to solve 1,000 of these type of problems, if I show you one, you will say, oh, it's so easy. If I show you 1,000, you will say it's easy, but it will take me a lot of time. So you can do this with a computer. So that's what I wanted to tell you. We chemical engineers take a lot of numerical methods in order to apply them into engineering problems. One problem will be, let's say you have distillation, have feed, this goes here and this goes here, and then it goes backwards. And you want to see, well, how does the equilibrium changes as we change temperature and pressure? Well, you want to see that. You want to change, of course, maybe temperature from 100 Celsius to 300 Celsius, and you want to change pressure from maybe 1 atmosphere to, let's say, 10 atmosphere. So there are plenty of solutions, and you will do that. And it doesn't mean only that you want to change two variables. When you change one variable, you change a lot of variables. So for instance, you change the viscosity, you change the density of the material, if you change pressure, you change the temperature of saturation, you might even change the humidity. That's for the substance. For the equipment, well, if you increase temperature of operation, you increase the heat it needs and so on. So one variable changes a lot of things right here. The number of trays as well will change, and the ratio will change, the flux ratio. So many variables will change. So that's why we need to model this via MATLAB using numerical methods or even Excel. Later on, I'm going to show you Aspen Plus and Aspen HYSYS are programs used to model such things without actually doing all the math that requires a simulation.
Bye.